Having understood the random selection process, let's get back to our question. We are asked to figure out the probability that a person picked at random from this data set makes over $50,000. Now, if all people made over that amount, then without blinking, I'd say the answer is 100%. But such is not the case with our salary level values, right?
I see it's called a variable for a reason.
Either the person makes over 50K or under that amount in salary. Classically speaking, our answer would become 1 in 2. The assumption we are making here is that it's just as likely for a person to make over 50K in salary than it is to make under 50K.
That doesn't sound right at all.
It doesn't. So what we will do is to split a salary level variable into two camps. One to house values over 50K and the other one for under 50K.
I smell a pivot table.
You're catching on, Lisa. I could have just used a filter, but what if our questions were more complex? Let's go ahead and build a pivot table by selecting some cell in that table. So I'm going to select a cell here, go to Data, Pivot Table. It is asking me to see if we can put the table in a new worksheet. I'm okay with that. And I get the pivot table builder over here. Because we also have gender related questions coming up, what I'll do now is to drag the sex variable into the row side of the builder and the salary level variable into the column side. And what we have is an empty shell with no entries. Let's have a closer look. Both of our variables are categorical, so when they have lots of levels, a pivot table would be a lifesaver.
It's time we filled up our pivot table.
What we need are the counts of people making over 50K. For that, let's drag salary level into the values field this time, okay? Now when I do this, the table gets populated. But had I picked a numerical variable such as age, then it would sum up the values, so we must be careful with those choices. Nobody is telling us that what numbers we see are correct or not. We're finally ready to take on question 1. We are asked to find the probability that a person makes over 50K. The answer is clear from the pivot table. Just ignore the person's sex for now and concentrate on the grand total row. Then the person's making over 50K is 7,507. So we have the ratio 7,507 over 30,160, which is about 0.25. Some of us like to express probabilities in percentage terms, so we can say that 25% of the people in our data set make over $50,000. I'd like to remind you that this is only a likelihood number based on this particular data set.